Welcome back to another episode in this Linux crash course. Today we're going to talk about processes and jobs, how you can monitor, start, stop, and even schedule them, or maybe even create your own service. So let's get at it. And just a quick reminder, all of this information is in this Git repo, right? So there's arcraven/linux-crash-course. We're on chapter 6 of this, process and job management. I'm not going to just scroll through and read this to you. We're going to cover most of this in a live session. So we're going to go to an Ubuntu session and we're going to cover most of this here. But it does talk about, for example, what a process is. And essentially it's an instance of a running program. And then it talks about down here a little bit what a job is. So I'll let you get that information from that web page, so from that Git repo. But let's go ahead and get into our Ubuntu session. So let's switch over to the terminal. I have a terminal here, and this is just running Ubuntu. I don't think that there's anything specific in this lesson that's going to be directly just for Ubuntu. So I think you should be good to go on other distros also. So the very first thing we're going to do is we're going to use the ps command. I'm going to run it once, and we're going to look at the manual here. So if you just run this natively by itself, you're going to get this output. So PID is a process ID. This is going to become important later on when we want to kill processes or terminate them. We're going to need these process IDs. This TTY column is the terminal device that's associated with this process. So PTS/0 is my terminal window here that I've got open. And you can see the command that was being run. So there's been a bash command run, which is this shell that we're running here. You can see that the PS command I just ran is listed here. And then the time is how long each of those processes took to execute. But let's go ahead and man PS so we can see kind of all of the information here. So man says, report a snapshot of the current processes. So again, this is important. So when you run PS, you're getting a snapshot of what things look like the moment you ran the PS command. There's a lot of information here. I'm just going to scroll through a little bit. We are going to start to use PS with this AUX. Is usually, or I see them in as AUX, but AXU to get a list of every process on the system. And so that's what we're going to be running here in a little bit, but you can see A is this option. Down here somewhere you're going to find, here's X, and presumably somewhere you'll find the U. So I'll let you scroll through the manual on your own. Hit the :Q to quit out of there. Let's go ahead and clear this out. Remember when I ran PS before, I only got the processes for my particular user. And you can see that if I add the extra columns on here. So we put UX to add the extra columns. And now you can see the user is Ubuntu. I'm getting all the processes for the Ubuntu user. The PID that's the process ID. That's the percentage CPU that this process has used. %mem is the amount of RAM that we use. VSZ is the amount of virtual space or the amount of virtual memory used by the process. And RSS is the amount of physical memory that is used. We covered TTY the last time, and you can see that these two are part of my console session. These are services that are being run under the Ubuntu user. And we'll talk about services in a little bit. The start is the time when this process was started, and the time column is how long or how much time that has been used for the CPU to run that process. So it might have been started a long time ago, but this one's only used 3 seconds, and that's the command. So let's come back to the stat or the status column. And instead of me explaining what all of the status stuff is, let's go ahead and pull up a web page here. We're going to go to, this is Ask Ubuntu, and let's go ahead and pump this up a little bit. But someone has asked this question about what that status column or the STAT column refers to. And so you can see the process states here. This is the accepted answer, and it's in man PS. So you can look up the manual, but you can see things like RST, which was we saw over here. So let's go ahead and see if we can get these both side by side. So you can see that this capital S means that's an interruptible sleep. That's what that is an interruptible sleep. The small s is it's a session leader. Capital R means it's running or runnable, so it's on the queue. And then the plus means that it's in it's a foreground process. So that's the command I just ran. I ran the PS UX command. So anyway, a lot of information here on the PS command. Let's go ahead and run the PS AUX command now. So instead of just UX, so it provides all the UX provides all these extra columns. Now A is going to list all the processes, not just for our Ubuntu user. So now that list is a little bit bigger. So you can see that starts about right. Here's where I ran PSAUX, and you can see processes that are being run by the root user. In fact, this is the very first process that was ever run on this machine when it first booted up. And that's our SystemD. We'll talk about that in a little bit towards the end of this video. That's our services. It starts up all of our long-running services. But if we scroll down, I'm not going to cover most of these, but you can see a lot of processes here from root. There's SystemD here, syslog. So there's a lot of other users that are running processes. But then here's our Ubuntu user. Our Ubuntu user has these processes running. So the PS command is certainly one way to visualize things, but there's other ways to visualize the processes. Remember, PS is a snapshot, so it's one instance in time. But if you want to see live, how are things looking, you can use something called top. So you can see that this is updated periodically, and it's taking snapshots, and then it's showing you what the changes are. So you can see things that are running CPU or memory. This top, I think, is a little dated. It's been replaced in my head by something called, and by the way, to get out, you Control C to get out. But top has been replaced by something called HTOP, and a little bit more visually for me pleasing, and it's also interactive. So now I can, click on certain processes. I can come down and kill that process, but I can use my mouse and click and move around a little bit. HTOP provides moving snapshots, right? So it takes a snapshot and then it shows you what it is, collects another snapshot, shows you what that one is. So you can see things moving around. You can also sort by different columns. So right now I'm sorting by percent CPU. This one is the process that's taken the most CPU. You can sort by memory, who's using the most memory, who's run the longest. You can sort by all these different columns. You can also see I/O. So here's the disk I/O, and you can see who's reading and writing to disks and all of that information. I'm going to go ahead and exit out of here. You can exit out by clicking the quit area. You can press F10 or you can hit Control C. I'm just going to go ahead and click quit. And there are also other packages that you can install to see the different processes. I installed one called Glances, and you can install it by sudo apt install Glances. When you run this, it'll install the package for Glances, and everything's been installed previously here, so I don't really get any new information. But then I can run Glances by just running Glances. Glances is a lot like HTOP, but it gives you even more information. So here are all the tasks that are the processes that are currently running. Here's the disk I/O. Here's the network I/O, so you can see all that information here. I found Glances useful to have all this information on one screen when I was doing some load testing on a server. And I wanted to be able to see which resource was constraining the server. Was it network bound, or was it I/O bound, or was it CPU bound or memory bound? So having all information on one screen, I found that a little bit more useful in that particular use case. But I just wanted to show it to you. I'm not going to come back. We're not going to use Glances here for the rest of this video, but just know that there are other ways to monitor the processes. So I'm going to Control C to exit out of Glances. Okay, so the next thing I want to do is let's talk about how we kill processes, right? So sometimes there's processes that are running and we want to shut them down. And let's talk about that. So right now I have one session open. So if I type in the command users and hit enter, you can see I have one session. It's an Ubuntu user that's running that session, and that's the only session I have open. In this same terminal, what I'm going to do is create another tab, and you'll see it pop up here. We're going to create a new tab. So I got two tabs. So here's the tab that we've been using, and I have a new tab here. And what I'm going to do is SSH in as the same user. Now I have two sessions open. So this session over here is our new session, and this is the previous session. So now if I rerun users, I should see that I have two sessions, Ubuntu, Ubuntu. So I have two sessions by the same user open. I'm going to clear that out. And over in this session, what I'm going to do is go and clear this one out too. I want to review a file, because in order to kill something, I need something running. So we're going to use this tab on the right to run a command or start a process. And then we're going to use the tab on the left to kill that command or kill that process. If I look over here, I have a couple of files here at the bottom. We're going to look at time loop for right now. And what we're going to see is it takes a parameter from the command line. We're going to feed a parameter in, and then it has this infinite loop. And what it does in the infinite loop is it prints our parameter that we took from the command line. And what we're going to do is we're going to feed it a session tag. This is session A, this is session B, session C. And then it's going to write this string, current date and time is, and it's going to print the date and time. This is going to get appended. So that's the appended, redirected to this file called output.txt. Then it's going to sleep for 10 seconds, and it's going to repeat this, and it's going to run this forever. So this is a long-running command. I'll run this in this session, and we'll get it started here. Again, I'm on the tab on the right-hand side, and I'm going to go ahead and run that time loop session. And you can see it doesn't return here. I get no information about that it's returned at all. I'm going to switch over to the other session, and now I have access to the same information. I'm going to go ahead and cat out this output.txt file. And you can see that I'm starting to get content in there. Now, when I ran it, I forgot to put a session ID in there. So what we're going to do is we're going to run it again, and I'm going to put a session ID in there just so we can make sure that that's clear. So I'm going to switch back over, and I'm going to Control C to stop that. I'm going to run it again, and I'm going to put a session ID of A in there. I'm going to hit enter. So I started this back up again. And over here, if I cat out output.txt, now you can see that's the session ID A. Now, that's going to be important later on. Not so important for this single running task here, but I can see that that's here now. All right, before we talk about stopping or killing or terminating a process, let's dive into what that really means. And so what I'm going to pull up is I'm going to pull up here a web page that talks about the difference between two terms, sigterm and sigkill, and what the differences are. You can read through this on your own, but what is sigterm and what is sigkill? So both of these are related to how Linux processes are stopped. One is more of a polite way to do it, and the other is just stopping it right away, and we're going to terminate everything that session has. So the polite way is to send a sigterm signal to the application or the process. Now, as a process, if I'm the application developer, I can actually receive that sigterm signal, and then I can save some data and stop any processes that I currently have running, and then I can gracefully exit my application. And so that's what sigterm is supposed to be used for. Ideally, all applications can be killed using sigterm. But we all know sometimes applications hang, and you have to use sigkill, which just pulls the process and kills everything associated with that process, and it terminates it right away. And so we're going to see the differences between both of these here, but that article kind of describes in detail the difference between sigterm and sigkill. So let's come back over to our terminal. So we're going to use our PS command like we did before with the UX, and we're going to see all of the tasks or processes associated with this particular user. And you can see over here is bin bash, and it's the time loop. I ran that earlier, so you can see that. Here along this left edge, we're going to see the process ID. So it's 123.001 is the process ID. Now, if I want to send a sigterm, again, that's the polite way to kill that process, to this application or this process, what we're going to do is we're going to type in the word kill. We're going to put in that process ID, which is 123.001, and I'm going to hit enter. This returns right away. I'm going to see if we can list the processes. I don't see that process anymore over here. If I switch tabs, you can see that it was terminated. So that's a kind of an indication that someone out there terminated this program. It wasn't just ran its course on its own and completed. It was terminated mid-process. So I'm going to restart it over here. The last time it said terminated, and I come back over here. Let's clear this out. We're going to use PS UX again to list all the processes. Here's our time loop. Start it again. Here's our new process ID. It's a different one. So we got a new one. So instead of being nice, what we're going to do is we're going to send a -9 option, with the process ID. So instead of sending a SystemD, which is what we did last time without this, when I include the -9 option, this is going to send a SystemKill. And so we're going to run this command. It returns, if I run PSUX, you can see that process is no longer running. If I switch tabs, now you can see that that process was killed. Our process over here understood that it was terminated, SystemD, and it was killed, SystemKill. So you can see the difference on the process itself. So that's how we would use the kill command to actually go in and stop that process. So let's go ahead and do the same thing with top and htop. So I'm going to start it up over here again. So in this session, I'm going to clear this and we're going to run top-u just so we can see just the Ubuntu tasks. So the processes used on top, just from the Ubuntu user. I can see the Ubuntu user here. Here's this time loop. That is right there. That's the PID that I want. So I'm going to go and copy that while it's still there. And to kill a process using top, what I want to do is type the K. K is going to bring me up to here. Now you see the PID to kill. And I have to type this in. And I'm going to paste the one that I had before, which is time loop. That's 123.078. When I hit enter, it's going to ask me what kind of signal that I want to send. And right now, the default is we're sending 15, which is SystemD. I'm just going to hit enter. And that process disappeared from our list. And you can see it all disappeared. And I come back over to our other session. You can see we got the terminated, which is SystemD. I'm going to start it up again. We'll switch back over here. We'll see it. Here's time loop. I'm going to get this new process ID. If I want to send a SystemKill, I can hit K again, put the process ID in, which was 123.093, which is that time loop. Hit enter. Instead of sending 15, which is SystemD, I'm going to type a 9, which is SystemKill, and hit enter. Same result on this screen. That process was killed. If I come back over to this process, now you can see it was killed there. So SystemD, SystemKill using top. Let's do it one more time using htop. So we're going to start this up again. Come back over here. I'm going to Control C to get out of top, clear it out. So now we're going to run htop, only showing processes by the Ubuntu user. So it's kind of a cleaner screen here. We can see, here's the time loop process right here. Now to kill a process with htop, it's, even though this is a terminal window, it's still responding to my mouse clicks. So whatever magic makes that happen, I can click this process, it'll highlight it. And now that it's highlighted, 123.100 is the process ID, I can come down, click the kill, and I'm going to click kill here. It's going to give me some options on the right hand side. 15 is SystemD, that's already selected. I'm going to hit send. And then you can see that process has disappeared from the process list. If I switch back over to here, you can see SystemD. It was terminated. Let's start it one more time. Let's send SystemKill this time. So it's running in this session. I come back over. I should be able to see it here again. Here's the time loop. I'm going to go ahead and select it by clicking it. I click kill. And now I come up to number 9, which is SystemKill. I select it and I send SystemKill instead of SystemD. And you see the process has disappeared. We'll come back over to our other session and indeed it was killed. So we killed it 3 different ways. We used the kill command, we used top to kill, and we use htop to kill the process. So that's how you can kill processes using their process ID. Let's address one of the challenges that we had doing that little experiment where we started something in this session over here, and then I switched over to this terminal window to kill it. Now I did that because I didn't want to talk about running things in the background yet. So we're going to talk about that now. So for now I'm going to come in here and I'm going to actually exit out of this session here. So we're going to close that session. I'm going to close that tab. If I type in users again, I'm just going to get one single session. So now I have a single session running. So let's talk about how we can get this process to run, but I want it disconnected from my shell, right? I want it to run in the background. I don't want it to run in the same process that I'm trying to run other commands in. And there's really a couple of different approaches. I'm going to list them and then we're going to talk about each one in detail. So the first approach is I can create a background job. The second approach is I can create a scheduled task, so it runs at a certain schedule. And the third approach is I can create a service. And so we're going to do all three in this video. So the first approach, there's really two options here to get something running in the background. I have, just as a reminder, I have my time loop, and that's that infinite loop that we saw before. So it takes a little bit of a session ID, and then it's an infinite loop. It just continually outputs things to this text file. And so if I want to start that, the way I normally would start that is I would just run it here, and let's give it a session ID of A, and it's running. Now the challenge that we saw is it's taken up my session. So now it's running. I'm waiting for it to end, but it's never really going to end. I want it to run in the background. So what I can type in is I can type in Control Z here, and it says it stopped this background process. It stopped it. It's kind of temporarily paused it. And then in combination with Control Z, what I can do now is type in BG for background, and that'll restart that process that I just stopped in the background. So right now, you can see it even hinted at the second way of doing this in a little bit. We're going to cover that little ampersand here. But now, this is now running in the background. How can we prove that? We can look at the output. Now, instead of catting it, we can certainly cat it like this. I'm going to go ahead and let's clear this out. There's a lot of content there. I'm going to remove output, so we're just starting again. But instead of catting it, we're going to use watch-n every 1 second. I want it to run this cat command. And so what we're doing is we'll start this up. Every 1 second, it's going to cat out that file. And you can see it just added a new line. My loop in that time loop shell script was every 10 seconds, it would run something. And so you can see session A, current time is this. 10 seconds later, session A, 10 seconds later, session A, and 10 seconds later, it'll run it again. So you can see that it indeed is running. That script is running, and it's running in the background. I'm going to Control C to get out of this watch command. If I run a command called jobs-L to list them all out, you can see that I have this one job. This is the process ID that's running, and that's the command that's running. So I'm going to go ahead, use what we had before, and we're going to kill that job. So if I list out my jobs, it's just say it's terminated. Eventually, that'll go off that list altogether, right? So it's no longer there. All right, the second option to run something in the background is a little cleaner. We don't have to do all that Control C, and you can see it's hinted at right here. If I just take that, and I'm going to paste it right here, that ampersand at the end is telling the shell to run this as a background task. So when I hit enter here, you can see it gives me the process ID that started, but I get my terminal window, my prompt right back. So I list out the jobs. You can see I have a task that's running the jobs. If I watch -n1 every 1 second, I want to cat out the output file, you can see that it indeed is going to be running here. So you can just see it just added a new 32. These are all from process A. So I'm going to Control C out of here. Now what if I did something like this? I reran this thing again, but let's run a couple of them. Session B, session C, D, E, just for giggles, let's put one more in there, F. So now I've started a bunch of these time loop processes. They're all going to be running. If you look at something like htop-u, Ubuntu, we should see a bunch of them. So here, A, B, C, D, E, F, they're all running. They're all taking up RAM and CPU. Everything's running here. So we're going to go and quit this out. Clear this screen. If I type in jobs-L, I can get a list of all the running processes. Given any PID, of course, I can copy this PID and I can type kill to kill that particular process. So if I list the jobs again, you're going to see that process is being terminated. If I refresh it again, it'll be off the list. So now it's off the list. So I still have 1, 2, 3, 4, 5 processes running. If I run my watch command on the output, I can see now that all of these processes, A, B, C, D, E, F, they're all contributing to the output of that file. So they're all pinning their own lines in there. I'm going to go ahead and Control C out of here. And to be honest, there may be some issue with writing to that file, all those processes trying to write at the same time. That's not what this video is about. This video is just about, being able to put things in the background. And we've accomplished that. We've got these things running in the background. One way I can pop something back into the foreground, see how this has got a plus sign by it? If I were to type an FG command and hit enter, then I get this command that was run, which was F. That one there in particular is now in the foreground. You see I didn't get my prompt back? I popped it back into the foreground. To stop this now, if this particular one's in the foreground, I can hit Control C and it'll stop that particular one that was in the foreground. If I look at my list now, that F process was indeed killed. Now I've got these remaining 4 jobs. So if I want to kill them all, there's a little bit of a shortcut here. We can jobs-P and that'll list all the process IDs. So if I take that output and I give it to the kill command, like that, it's going to send all these process IDs to the kill command, and it's going to kill every single one of those processes. So now if I come back in and I list them, you can see that they're all terminated. A short time later, they're all gone. So that's manually running something in the background. So I started those all manually and I pushed them all in the background. Okay, let's talk about the second way of getting a process to run unattended. So it's in the background for me, and that's by scheduling it using a cron job. I have this other shell script here called schedule. Let's just nano that out and we can see what that looks like here. So it's another bash script, and all it's going to run is it echoes out ran at this some timestamp back into that same file. That's the file that's going to run. In fact, I'm just going to go ahead and instead of using that, I am going to make this a full path. So instead of using a relative path, it's a full path now. I don't know if that was going to be an issue here, but it won't be now for sure. So we're going to go ahead and Control X out of here, and yes, we'll save that and hit exit. So I have my scheduled.sh, and what I want to do is I want to schedule that to run, let's say, every second. I'm going to delete the output.txt file, so that's gone. No output.txt file. Just to see what that scheduled output's going to look like if I run this manually once and then I cat out the output.txt file, you can see it says ran at, that timestamp. If I run it one more time, cat it out, it should see another one appended, and I ran it, like 21 seconds later. So before we get into setting up my cron job, I want to come over here and we're going to open up a page just to allow us to kind of explore cron expressions. So if you don't understand a cron expression, it'll be hard for me to explain setting up the cron tab or the cron job here. But there are these expressions that look like this. So there's 1, 2, 3, 4, 5 asterisks. So this first asterisk is the minutes, and have values between 0 and 59. The second asterisk represents hours, and you can see that the values between 0 and 23. The next asterisk is the day of the month, 1 through 31. The fourth asterisk is the month itself, and the last is the day of the week. So if, for example, I want something to run every minute, I provide all 5 values with asterisks. And it's like a regular expression. So when it matches, think about the clock ticking along. When the time actually matches this regular expression, then whatever the job is, it's going to run that job. So here's every minute. If I want it to run every hour at the top of the hour, I put a 0 in there. So when the minute hand hits 0, that means it's going all the way back around. It's at the very top. That's at the top of an hour. And so it'll run every hour. If I want to run, say, every day at midnight, I can put another 0 in here. Here's some very common cron expressions that you can see at the very bottom. So it's very powerful. And what we're going to do is we're just going to set our cron job up to run like this. It's going to be every minute. So I'm just going to go ahead and copy that. It's not too hard to type it in, but we're going to come back to our terminal window. And what we're going to run is something called Crontab. And to actually edit the expression, I put a -E in here, and that's going to let me edit it for this particular user. Now, the first time you run this, you may get a different initial screen asking you to choose an editor. I chose Nano for my editor. But you can choose whatever editor you want. And at the very bottom down here, I already have entered this cron expression that I want to run. So I have 5 asterisks, and then I give it the command that I want it to run. So we're going to run /home/ubuntu/scheduled.sh. That was the path to that script that I wanted to run. So every minute, this is going to run that script for me. So I'm going to go ahead and exit out, Control X. I'm going to save the modified buffer, and you'll see right away that Crontab says, okay, I see that you've changed something. I'm installing this new Crontab. Now what I want to do is I want to set up my watch. Every second, we are going to cat out that output.txt file. You can see it's already run once because I ran this twice manually. You remember it was 21 seconds apart, and it's already run once here. And it ran pretty much at the top of the minute. And you can see there's a slight delay, a 1 second delay when it actually ran that first time. So we're going to sit and pause here for a second and let it run. I'm expecting some output within the next minute though. I mean, ideally it would be at 16:12:00, but let's see what we get here. And there you go. So 16:12:01. It takes a little bit of time just to schedule and execute the command. It's not going to be super precise. It didn't run exactly at that top of the minute type of thing, but it did run around there. Cron tabs are very powerful. You can imagine if you had something, for example, a backup script. You want your MySQL dump script to run once a night at midnight. You could run it through here. You can set up the Crontab expression, set the expression to run once at midnight. So let's go ahead and exit out of here. Control C. To stop that Crontab, if I don't comment that line out, it'll continue to run forever. But to stop a Crontab, it's the same thing. As I edit the Crontab expression all the way at the bottom, I'm just going to comment this out. So now that will no longer apply. I'm going to Control X to get out of here, save the buffer, and you can see that Crontab has automatically seen and recognized that we've modified and changed this. So that's the second way of running tasks or processes in the background. The first way was we ran background tests manually. The second way was we used Crontab to schedule something once a minute. All right, the third way that we can have something run in the background unattended by us is we can set up and create a service. Now, I'm not going to go deep into this, but Linux has something called SystemD. We can configure SystemD to run a script as a service, and I'm going to show you how to do that. But before we do that, I'm just going to pull up a couple of tutorials here. This is a good tutorial by DigitalOcean, talk about SystemD essentials, services, units, and journal. I'm not going to read this. I just want to point you at certain things. I'm going to have a couple of videos in the future talking about Nginx and possibly other services. And when we come back, we'll start to use Nginx like this, where we start Nginx service and we stop it. But for now, we're going to create a service of our own. So I'll pull up another web page here. This is creating a Linux service with SystemD. This is by Benjamin Morel. Hopefully I pronounce your name correctly. And he has kind of an example. He went through a PHP program, but we're going to do something even simpler for us because we already have these scripts. We're just going to set up our script so that it runs as a service. So we're going to use this process here, creating a service file. Okay, so let's come back to our console window. And the first thing we're going to do is we are going to create this test service. And I'm going to run this nano. So we're just opening up nano as an editor. /etc/systemd/system, and then this is our new file that we're going to add in here. And I'm going to copy and paste the content of this file. And so for the description, I just have it's called test service. I'm not going to go through pretty much any of this stuff. You can look at that article that I just shared, but this is the simple type of service. Down here, we're going to run this as Ubuntu. And this is what we're going to execute. We're going to run bash, and we're going to have it run our script, and then we're going to feed in this parameter. So when we look at our output, this is our time loop. This is the name of the service. It should say service, and then it'll say whatever the current time is. And so we're going to exit out of here. So now we have this configuration for our test service. We can actually start our test service. Before we do that though, I just want to make sure that our output file is here. I'm going to remove it just so we're clear on where the output's coming from here. So we'll clear this out. To start our service now, we can use systemctl and start. And our service was called test. So I'm going to run that command. To see the status of our service, so once we start it, we can take a look at the status, and we can see that this service is now running. Now, I started this service manually with this command right here. If I want this service to start every single time the system is rebooted, I need to enable the service. So I can enable the service like this, CTL enable test. And so you can see the output of this. It created a symlink from our service file to something in the service default.target.once, and now I have this symlink. These are all the services that are going to get started up when the system restarts. And so now when the system shuts down and it comes back up, our service should be running right away. Again, I'm just going to check the status of the service. You can see that it's running still. Let's go ahead and run our watch-n 1 second cat out the output. Let's see what we get here. So you can see the prefix is service. That's what we fed into our service when we started it. And it's running, and it looks like about every 10 seconds. That's the sleep in our while loop. Every 10 seconds it's adding a new line or appending a line to this file. So indeed, our service is definitely running. I'm going to Control C out of here. To stop our service, we're going to run the system CTL command again. And we're going to type in stop, and then we'll give it the name of the service. If I run the status command now, we could see that our test service was killed, it was terminated. Down here you can see it stopped. :Q will get me out of there. Now if you recall, this service is no longer running, but if this Ubuntu instance got restarted, it would automatically start the service back up. But let me go ahead and disable this service. So by disabling the service, what I'm going to do is I'm going to remove it from those services that are run at startup time. And so now you can see it removed that symlink. So that's it. That's the third way to run processes in the background. Okay, so we've covered a lot in this video. We started off by just monitoring and how can we view processes that are running using PS, top, htop, glances. Then we talked about how to kill processes, politely, and the not so polite way would tend to send a kill signal. So then we looked at 3 different ways of running a process unattended. I can push stuff in the background manually. I can have Crontab schedule a process, so once a minute it runs, or I can create a service using SystemD and have SystemD run that service manually for me. SystemD has a lot of features that you want to dig into a little bit. Like, for example, what does SystemD do when your service for something crashes? So if our script crashes, what does SystemD do? Does it try to restart it? Is there a delay in restarting it? How many times does it restart? So all of those things are in SystemD. You can take a look at a couple of those websites that I shared. A lot of that content is in there, and hopefully we'll have future videos on SystemD. So that's it for this particular video. If you like content like this, hit that like button and subscribe. I'll see you next time.